Welcome to machine learning, and today we want to take you through linear regression. And linear regression is one of the first and the simplest methods of machine learning. And today we are going to apply simple linear regression, multiple linear regression, and create interaction terms in linear regression, and also interpret the output of linear regression. So we are going to use RStudio. If you do not have RStudio, you can download it through the link in the description. We're also going to use insurance dataset, and you can also download it in the description as well. So first of all, I'm going to work on my working directory, which is, I'll just set my working directory, which is going to be C. So I'm just specifying my working directory. So this can differ with you. If you have your dataset somewhere else, you can call the location here. So this is my directory, and I'm going to load the data as insurance, DAT, and RDA. Right, so I've loaded my dataset. The next thing, I'm going to load my packages, which I'm going to use. So to load them, I use library, and I'm going to use ggplot2. This will be the library I'll be using for visualizations. The next thing is to understand my data. So I'll start by looking at the first 6 rows of my data, and also I can see the last 6 rows of my data. Right, this is just for me to know my data set. The next thing I can do is to check the dimensions, which is dim, just to check the number of rows and columns. I can also check the structure of my data, and we can see that there are some integers and some vectors and numeric variables. I can also look at the column names of my data. Right, so these are the column names, and we are going to use these variables to make predictions on the charges. So we want to predict the charges, which is the premium. So yeah, that's it about our data set. We can further analyze our data. We can also look at the number of rows which are unique, so that we check for duplications. So n rows unique, unique rows, which is insurance. So you can see we have 1,337 rows which are unique, but our dimensions, when we checked, it shows that we have 1,338. So which means there is a duplication. So we need to remove that duplication. In order to remove it, we are going to create a new dataset called insurance, and it will have the new entries without duplication. So in order to address that, we are going to use the square brackets. Whenever you use square bracket, it means you want to do manipulation. And if you want to manipulate the rows, you do them before the comma. And if you want to do manipulation of columns, you can do that after the comma. So I want to do that before the comma for my rows. So I'll say not duplicated insurance. That means my rows will not be duplicated. So we can just check that. Insurance. So we now have 1,337 rows which are unique. So then this is a success. The next thing we want to do is to just look at our summary of the data. Right, so you can see the statistics for each variable so that you better understand your data set. The next thing is to investigate the response variable. The first thing that comes in mind is just to take a summary of that and see the summary of our response variable. Right, you can see that the response variable values are starting from 1,122 to the maximum of 63,770. And also you can look at the mean and the median. Once you see your mean being greater than the median, it means that there's a presence of positive outliers in the data set, which translate to the data being skewed. So you would not want to work with a skewed response variable. So you can also better see this through visualization. We can create a new plot, and we are going to name it G1, and we're going to use ggplot. We want to see the distribution of our response variable. So for ggplot, you specify your data, which is insurance, and you specify the axis. So I'm going to use charges being my x-axis. And the next thing, we are going to use geometry, and you specify the geometry, which is a density. We want to see the distribution of this response variable. And field, that means we want to specify a color. This is not required, but you can just do it to enhance your plot. And also you can work on your transparency through using alpha, and you can also work on your theme. If you want to make changes to the theme, you can use this. And also to apply the changes, now we are going to make changes on our background. We don't want the background. And we can also work on our grids. Grid major, we don't want this, or we need to remove it. And we also need to remove the grid minor, so I don't want this. Dot minor element blank. And also I want to remove the border, so element blank. The next thing I want to do is to work on my labels, that is my labels. So labels, I want to start with my X label, which is my charges. I can also work on my title. Which is charges distribution. Right, and after doing this, you can call your plot, which is G1, and just run everything. Right, so this is my plot, and it shows that the majority of the charges are below 20,000, and there is some skewness, which is the right skewness over here, and also we have other greater values which are even greater than 60,000. So you can't do any modeling or any analysis, further analysis with this skewed response variable, especially when you're using simple methods like linear regression. You would want to transform them. So in order to transform them, there are several ways. One of them is log transformation. So we want to see how log works. So in order to see how log transformation work, I'm just going to illustrate how it works here. So let's say we have log, we have numbers of 1 to 10,000. So I'm going to say 10. We want to see the impact of log on these numbers. And I'm just going to list a log of different numbers and see the impact. Right, so we want to see how log will compress these numbers. So as you can see now, our numbers started from log 1, which is now compressed to 0, log 2, log 10 to 2, log 100 to 4, log 1000 to 6, log 10,000 to 9. So it just shows that the log transformation compresses these numbers so that the difference won't be that much. Right, so the next thing is we want to apply that log transformation on our response variable. Maybe we might try to compress the numbers, the 60,000, to become close to the smaller numbers. So to do that, we are going to create a new variable called log charges, and the log charges is going to be log of our response variable, which is insurance charges, right? And you put a 1. So the reason why we are putting a 1 is if we have, for instance, if we have a price of 0 or a charge of 0 in our data, just in case, if we have 0, log of 0 will give you a negative, so a negative infinity, so you wouldn't want that, so you put a +1 so that we will never have a log of 0. So the next thing is to input these log charges in our dataset. So our dataset is insurance, and we need a log charges variable. So we are going to say log charges. So we are creating a new variable called log charges in the insurance dataset. Now we can also see the summary of this new variable to see if the log actually transformed our dataset. So to do that, we're going to say insurance log charges. Now you can see it's now running from 7 to 11, so it actually removed the large differences that was in our dataset, and we can now plot to see how it looks on a plot. So let's see that. ggplot insurance, yes, and we specify the x being, now we are using log charges, and we want to see the density of that. Yellow is equal to blue, and our alpha should be equal to 0.3, and we work with our theme. Then we apply what we want on our theme, which is element remove, and we can remove also the border. We just want it to be plain. Element blank, we can see element, we are removing the grids. So let's try to run this and see if there's a difference now. Right, so you can see the plot is now closer to a normal distribution, but though it's not perfect, but it's much different from what it was at the beginning. So this is what you can do in order to prepare your data and your response variable for a model. So yeah, that was this part. In the next part, we are going to create our first model using the newly transformed dataset. Thank you so much. Don't forget to subscribe. Watch out for part 2.